streaming key that you have copied from YouTube Studio. Now we are ready to live stream our event. Click on the Start Streaming button on OBS. Note that it will automatically trigger the Start Recording button also. Now if you go back to YouTube Studio, you will see a video is being uploaded to YouTube server and you can preview it. When you are ready to go live, you can press on the Go Live button on the top right. On OBS. Note that it will and you can preview it. When you are ready to go live, you can press on the Go Live button on the top right.
If you wanted to be able to live stream your events to social media platforms like LinkedIn, YouTube, Twitter and Facebook, and have you wanted to be able to do that with Microsoft Teams? If you have, then keep watching because this is the video for you. I'm going to show you the whole end-to-end process for doing that. But first of all, the question is why? A lot of corporate webinars and similar events tend to move to social media platforms because people don't want to necessarily commit to a different technology to join a webinar, and they do want a more informal format as well, and of course you need a bit of polish to differentiate yourself from the crowd. Now, Microsoft Teams has webinar functionality.
Now again, trigger the Start Recording button also. Now if you go back to YouTube Studio, you will see a video is being uploaded to YouTube server and you can preview it. When you are ready to go live, you can press on the Go Live button on the top right.
Good morning, pa. இல்ல ரெண்டு பேர் வருவாங்க, எஸ்பிஎம் மொத்தவங்க வருவாங்க, நியோனிமா மொத்தவங்க வருவாங்க.
If you wanted to be able to live stream your events to social media platforms like LinkedIn, YouTube, Twitter and Facebook, and have you wanted to be able to do that with Microsoft Teams? If you have, then keep watching because this is the video for you. I'm going to show you the whole end-to-end process for doing that. But first of all, the question is why? A lot of corporate webinars and similar events tend to move to social media platforms because people don't want to necessarily commit to a technology to join a webinar, and they do want a more informal format as well, and of course you need a bit of polish to differentiate yourself from the crowd. Now, Microsoft Teams has webinar functionality, which is really good, and there's new stuff that's came to Teams, like standout mode that allows us to put ourselves into the meeting, that make all of this content really, really good. And Teams live events are very easy to use and set up, but sometimes you want to get to the platform that your people are on. And when you're using a third-party tool like StreamYard, then those aren't bad tools. However, they're not so great for people who are presenting at your event. So if you've got people who are presenting at your event and they're used to using Microsoft Teams, they'll expect functionality like together mode or perhaps background blur or background replacement to just work. They'll expect noise cancellation. They'll expect it to work well with the right headsets that you've already purchased for your staff. And of course, joining one of those web-based tools, then the video quality is usually okay. However, you won't be able to replace your background, you won't be able to have noise cancellation, and often people have trouble picking the right microphones and stuff like that. Now, what we're going to do is we're going to go through all the steps. So by the end of this video, you'll know exactly what you need to do to live stream an event from start to finish. We'll start with the administrative tasks where we need to enable this for our Microsoft 365 environment. We'll also have a look at the tools we're going to use. So NDI is one of those, OBS is another of those. We'll go through the setup of those. They're straightforward to set up, industry standard tech. And we'll also connect it to our live streaming platform and stream out over YouTube. and we'll show you that full end-to-end process. And it's straightforward. So within the next quarter of an hour, you're going to learn how to do all of this. So let's get started. As an admin over in the Teams Admin Center, I need to go and either adjust an existing meeting policy so that it supports OBS. So if I want to do this for everybody, I click on Global Org-wide Default, and then I can switch on NDI Streaming. If I want it just for the people that are going to act as our producers, the people that join the meeting and then press Start Broadcast, then I can create a new policy, and inside that new policy, I can then go and add in NDI Streaming. Once that's enabled, then they'll be able to stream. Now, if I need to get my computer set up and ready to go, then I need to install OBS first. So you go to the obsproject.com website, and then if you're running Windows, download the Windows version. Now, you'll also need the NDI plugin. So that's found within the OBS website, and if you search for OBS-NDI, you'll find it. Now, we'll click on the link to GitHub, and that's where you'll find the download. Scroll down to Releases, and then you need to pick the Windows installer. First install OBS, then install the NDI plugin. With both of those installed, we'll be ready to go. Now, I've pre-configured OBS with some of the bits that we need. Now, OBS is split into several sections, but it is fairly simple. We have scenes, and the scenes are the things that we'll cut between. So the scenes are our different layouts. They contain the graphics, the backgrounds, and they'll contain our video streams. And then for each scene, we've got a list of sources. Now this one just has a single one. So when you watch Practical 365 on YouTube, then you'll see an intro, and that is, as you can see on the screen here, a video, and then we've got the end of the video that you'll see here. Again, this is just a video file that gets played. We can add all sorts of sources, and you'll see in our list we've got NDI, but we can also add in things like display capture, audio input capture, media, text. We can arrange things as we want. It's very straightforward. As a producer, we can do something very interesting inside OBS, so we can make sure that our presenters can see the video feed that's going out. We can do that by choosing to start a virtual camera. What that will give us when I press this is the ability inside Microsoft Teams to be able to actually see what everybody else is seeing. They won't need to go to that YouTube page to watch the stream. It will be there for them to see. Now, before we can start streaming, then we'll need to set things up. So if I now go over to YouTube Studio, then I can set up OBS to work with this. So it's very straightforward. All I need to do is go and find the stream key and press copy. And then over in OBS, I'll go into stream, and then I'll pick YouTube from the list, and then I can paste in that stream key. That's going to allow us, as soon as we press start streaming, to go live. I'm not going to do that yet though. So what I need to first of all do is get Teams to interface with OBS. Now that's pretty straightforward. I'm going to go to Settings inside my Teams client. I'm the producer for this, and I'll switch on NDI. That's going to enable it for any meeting that I want. However, I'll need to start NDI to actually make it work. So I'm going to press computer audio. I'll just show you the webcam feature here, where you can see what the viewer would see and share that with the rest of the meeting. They won't see it reversed like that. That's just mirrored because it's expecting a webcam. I'll turn that off for now though. Now I'm inside this meeting. It is just a standard meeting. Right, you can see the meeting room device that I've got behind me just here. And you can see all of my participants, and you can see the screen share that's also going on alongside this. To get everything ready, I need to set up the meeting so it all works the right way. So I'm going to press on the ellipsis, and because I'm going to use a panel session in this, I'm going to add together mode. So that's the same one that you can see over my shoulder here. I also want to be able to make sure that we can see the video feeds for all of the participants as well. Now, in the Teams client, although NDI is going to take the individual video streams, we do have to make sure that they're actually displayed on screen. So that makes sure that the Teams client itself has configured itself to receive the video feeds screen share. So we've got to do a couple of things to get that up and running. And I do that by clicking on the ellipses for each person and I'll choose pin. So I'll go through these in order, very quick. These are all the people that we want to be able to view in the meeting. I'll press pin for all of these people, and now you'll see that I've got my together mode scene and I've got all of my people. Now what you see on the screen here, that's not what we're going to share. We're not going to share a screen grab of this. What we're going to do is click on the ellipses and now press broadcast over NDI. Now, not much changes once I do this. Our meeting presenters will see a warning telling them that this is going to be broadcast over NDI, but until you actually get those meeting streams, nothing actually happens. Now, if I open up my client here, then this is where I'm going to be able to add in my panel session, add in my participants, all of the components that I need for my live broadcast. So if I click on interview with background here, you'll see what I prepared earlier, and you'll see straight away I brought in 2 different panelists to have a chat over Teams. If I click on interview with full screen, then I've done the same, but I've got a side-by-side view. Now, to make this work, what I need to do, and I'll click on panel session here, is add my NDI source. So you'll see I've already arranged this with a transparent PNG image. I've also added in a title, and that is just freeform text that I added in, and in the background I've got a video that's on a loop, which is this one behind us here. Just on a loop over and over again, gives it a little bit of style. Now this backing screen here I added as a placeholder so I can see the dimensions that I want, 1440 by 810. Now you could literally just choose to drag and drop this to the size you want. So I'll show you that first, and then I'll show you how we can be a little bit more clever when it comes to sizing the content if you want to make sure that it always displays the same way. So I'm going to call this panelists, and I'll choose a source name. This will be audience from the list here.
எங்க வேணாலும் உட்காந்துக்கா, எல்லாருமே ஹெட்செட் தான் போட்டு போயிருக்கேன். எனக்கு மட்டும் ஹெட்செட் இல்லாம, ஏன்னா யூடியூப்ல கனெக்ட் ஆயிருக்கனால ஹெட்செட் இல்லாம ஒன்று எனக்கு மட்டும். அது மட்டும் தான் எனக்கு, வேற ஒன்றும் கிடையாது. ஆமா, என்ன அதனால தான் இங்க கடைசிக்கு வந்துட்டேன் நான். அதெல்லாம் ஒன்றும் அடிக்காது. வினோதினி மேம், நீங்க முதல்ல அட்மின் போட்டீங்களா இல்லையா? நான் காலேஜ் மெய்டி வச்சிருப்பேன், அதுலதான் யூடியூப் ஓடிட்டு இருக்கோம். ஆனா என்னோட அக்கௌண்ட்ல தான் நான் ஜாயின் பண்ணுவேன். நீங்க இன்னும் ஓபன் பண்ணலையா மேம்? இல்ல, என்னது நீங்க அக்செப்டன்ஸ் கொடுத்துட்டீங்கன்னா நான் சாப்பிட போறேன், வேற ஒன்றும் கிடையாது.
மேம், எஸ் மேம். கேக்குது மேம். தேர் பிரீத்தி.
என்ன மேம்?
டிலே ஆகுது.
கொஞ்சம் டிலே ஆகி தான் வரும், உடனே வராது.
இன்னும் நீ கொஞ்சம் கரெக்டா அட்மிட் கொடுத்துட்டே இரு. ஏன்னா எல்லாரும் நம்ம ஜாயின் பண்ணுவாங்க.
ஓகே மேம் ஓகே மேம் ஓகே மேம்
சார் நீங்க யூடியூப்ல இருக்கீங்களா?
ஓகே மேம்
லிங்க் இல்ல உங்களுக்கு லிங்க் அனுப்புறேன். நீங்களே லிங்க் வந்து லிங்க் க்ளோஸ் பண்ணுங்க. சூரிய பிரகாஷ் அது ஓபன் இத க்ளோஸ் பண்ணுங்க. இது இன்னொரு இல்ல இல்ல எனக்கு கூட்ட சொல்லுங்க. Yes, it's good. Contact ya. Nah, ada video kan buat contact sama kita. Video kan contact. Okay. உங்களுக்கு பேசுறது ஏதாவது எக்ஸசைஸ் இல்லையா? சரி. ஆனா இப்போ நீங்க பேசுறது என்னடா நம்ம கேக்குறேன். அத ஏதோ நீங்க கேக்குறீங்க. தண்ணி எடுத்து சொல்லலாம் பக்கத்துல வரறாங்க. சார். அம்மா நான் கேக்குறேன். என்ன கரெக்ட்டா இல்ல. நெட் இருந்தால ஒரு பவல் அப்புறம் பாத்துக்கலாம். நெட் கரெக்ட்டா இருந்தா அது ஒண்ணும் கரெக்ட்டா இருக்கு. வைஃபை போட்டீங்கன்னா வைஃபை தான் கரெக்ட்டா வரும். லேண்ட் ஆயிடுச்சா? இப்போ லேண்ட் கனெக்ஷன் வச்சுக்கோங்க. நீங்க உங்களுக்கு லேண்ட் இருக்கா? லேண்ட் போட்டுருக்கா? எதுக்கு லேண்ட் போட்டுருக்கு? ஒரு வயர் இருக்கு. அது கேட்டீங்கன்னா ஒரு ரோட் ஆர்டர் பண்ணிட்டேன். 100 use this you can also view the presentation in YouTube link போட்டு அது நான் ஒரு மெசேஜ் அனுப்பிச்சிடுறேன். நான் ரெடி பண்ணி வச்சிருக்கேன். டாக்டர் ஃபார்வர்ட் பண்றேன். அதான் உங்களுக்கு அவசியம் வரணும் நான் பாத்துக்கலாம். என்ன போட்டுறோம். அவ்வளவுதான் வேலை எல்லாம் ரெடியாப்பா? பெஸ்ட் இருக்கா? பெஸ்ட் இருக்குங்களா? 9:40 வந்து சொல்றேன். சரி. இது இதெல்லாம் ஓகே. இதெல்லாம் நான் பிரச்சனை ஆகுது. இல்ல 12 மணி மேல பாத்துக்கலாம். சரி. நான் பாத்து வந்ததா? ஆமா சார். எல்லாத்துக்கும் ஒரே நீங்க தான் இருக்கீங்களா? ஃபைல் காப்பாங்க. ரோஸ் ஃபைல் இங்கேயே. எதுல இல்ல. இப்போதான் எடுத்து வந்தா மார்க் ஃபைல் போட்டு நம்ம பேசுறது எல்லாம் எடுத்து வந்தனே. அங்க கேக்குறீங்களா? அங்க கேக்குதா பாருங்க. இங்க டேபிள் வச்சா இங்க டேபிள். இது இருக்கீங்களா? யாரு நீங்க உட்கார்ந்து டேபிள் ஏய் பரவாயில்லை பண்ணுங்க. Pink color files. இங்க இருக்க மாதிரி தெரியல. மேலே பார்த்து நான் உங்களுக்கு லேண்ட் கான்டாக்ட் பண்ணுறேன். எந்த கிடையாது அது இப்போ நான் மேலே ஓகே போடுமா? கொஞ்சம் ஸ்லோவா இருக்கும். ஓகேயா? ஓகே அது இன்னும் பார்க்கல. ஓகே லேண்ட் எடுக்கலாம் சொன்னா. அப்படினா ஓகே இருக்கும். ஓகே. எனக்கு லேண்ட் கனெக்ட் ஆயிடுச்சுன்னா யாருக்கு கனெக்ட் ஆயிருக்கோ அப்படியே அதே பேசுறேன். ஆனா 7 பேர் தான் இருக்காங்க. நைட் பார்ட்டி ஆரம்பிச்சோம்னா 9 பார்ட்டி
சொல்ல வாட்டீங்களா இந்த டிபார்ட்மெண்ட் பைசில இருக்கோம் என்ன ஐசி தானே நான் பிளான் பண்ணேன் நீங்க ஐசி எல்லாம் ட்ரை பண்ணலாம் ஷெல்டர் எல்லாம் ட்ரை பண்ணலாம் எனக்கு பிளான் கனெக்ட் ஆகல க்ளோஸ் நீங்க எனக்கு தெரியுங்க
என்ன வச்சிருக்கீங்க அந்த வாரம் தெரியல 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 என்ன கிளாரிட்டி கரெக்ட்டா அந்த வாரம் தெரியல இது
இந்த ஸ்கிரீன் இருக்காங்க
Good morning, participants. Good morning, Janil sir.
Good morning, ma'am.
Good morning, sir. Very glad to welcome you, sir. The session will start within a few minutes.
Yes, ma'am.
Kindly wait, sir.
Okay, ma'am.
We'll start after 5 minutes, sir.
Yes, ma'am.
Okay, kindly wait.
அதான் இது ஐட்டம் டாப்
அதிகமா இருக்கு போல
இல்ல மியூட் பண்ணீங்க அவர் வந்தாலும் போட்டு
நானே ஒயர் இல்ல நம்ம மொபைல்ல ஒயர் லேப்டாப் வேற போடும்
உங்களுக்கு என்ன கதை சொல்றா
நீ அந்த வாட்டாங்க நான் குப்பல நான் வாங்க மாட்டேன் நான் ஜாயின் பண்ணலாம்
இந்த ப்ரௌன் கலர் மொபைல் இது ரெண்டாவது
அதான் சாப்பிடுங்க
Good morning, madam.
ரைட்டு ப்ளஸ் அவங்க சங்கியா பண்ணி ரெண்டு தடவை போடுறாங்க.
Good morning, sir.
Good morning, sir.
Good morning, Jamil, sir.
Good morning, sir. Good morning, madam. Good morning to everyone.
Good morning, sir.
Good morning. Good morning to everyone.
Sir, shall we start the session?
Yes, madam.
Sir, can we start the session? Shania, ma'am, please start the session.
Yes, ma'am. Wonderful good morning to anyone who joined the virtual mode. It gives me immense pleasure to welcome you all for the inaugural function of One Week International Online Faculty Development Program on Trends and Innovations in Industry 4.0, organized by Department of Instrumentation and Control Engineering. Let me start with the words of Aristotle. Teaching is the highest form of learning, and research is the manifestation. Therefore, this FTP is mainly to involve everyone so that all of us can learn from each other by interactions, discussions, and deliberations, which in turn open up the doors for many innovations and thereby helping the society. This day is a much awaited day for us in the beginning of 2023. One of our most admirable person usually says us that the price of success is hard work, dedication, and determination that whether we win or lose, we have to apply the best of ourselves to the task at hand. She is none other than our most admirable Dr. S. Vadivarikima. I request our head of the department, Dr. S. Vadivarikima, to welcome the gathering.
Honorable Administrator, the most respected Director, Principal, Vice Principal, Dean Academics, R&D Director, guest of today's session, Director and heads of various departments, staff members, and dear participants in and around India, good morning to one and all. I am extremely happy to address you in this prestigious moment when our Department, Instrumentation and Control Engineering conducts One Week International Faculty Development Program on Trends and Innovations in Industry 4.0 in virtual mode. On behalf of the Department of ICE, I heartily welcome all of you for the inaugural function of this FTP. I cordially welcome Dr. M. Sindalamurugan, Director, AVC College of Engineering, for his consistent support towards the implementation of our ideas and also to have agreed to give the inaugural address on this occasion. Welcome, sir. I wholeheartedly welcome Dr. C. Sundarraj, Principal, AVC College of Engineering, for support and guidance for conducting this FTP. Welcome, sir. It's my great pleasure to welcome our guest of honor, Mr. Jamil Santiago, Teaching Faculty, University of Technology and Applied Sciences, Salalah, Sultanate of Oman, who is going to handle the first session of our FTP. Welcome, sir. Also, I would like to welcome all the resource persons who are attending this inaugural function. So, welcome all our respected resource persons. I feel immense happiness in welcoming our participants, that is, teaching faculty, industry persons, research scholars and PG scholars from all over the globe who play a vital role in carrying out this FTP in a successful manner. Welcome, dear participants. I welcome Dr. K. Surya Prabha, Mr. K. Aruselvan and Mrs. M. Vinodini, coordinators of this event, whose efforts are tremendous in successful implementation of this activity. I humbly welcome all the heads and directors of all the departments for their virtual presence. Alone we can do so little, together we can do so much. I would like to welcome all the teaching and non-teaching staff members of our department. The aim of this faculty development program is to enrich the knowledge of faculties through interaction with eminent personalities from industries and academics. So I request all the participants to attend all the session to equip them with sufficient knowledge in Industry 4.0. I once again welcome you all for this activity. Thank you.
Thank you, ma'am. An idol of mastery, experience and inspiration to all of us. It is indeed a matter of pride to have our beloved director, Dr. M. Chandran sir. I would like to welcome our director, sir, to address the gathering.
Good morning to all. Respected eminent speaker of morning session, Engineer Jamil, University of Technology and Applied Sciences, Oman, and other speakers of 1 week International Faculty Development Program. Respected Principal of AVC College of Engineering, Dr. C. Sundarraj, dear Vice Principal, Dean, Directors, and heads of various departments, as well as faculty members of various departments, organizing secretary, conveners, and steering committee members of this program, learned participants from various institutions. I extend a warm welcome to this 1 week faculty development program in the emerging topic of trends and innovation in Industry 4.0. Our Administrator, Honorable Justice K. Venkataraman sir, always insisted me to motivate our faculty members to conduct more number of programs as well as to apply more number of research proposals to various funding agencies for the benefit of our institution. I take this opportunity to congratulate Organizing Secretary Dr. S. Vadivaragi, Head of Instrumentation and Control Engineering, conveners, steering committee members, and everyone involved in this FTP program. And also record my sincere gratitude to the Department of Instrumentation and Control Engineering for organizing this international program through online mode. At this juncture, I appreciated the staff members of ICE department. Instrumentation and Control Engineering is the growing field in the industry. I hope this FTP program will create an impact and also create a spark in the minds of participants to ignite themselves to the higher level. Dear participants, to utilize this opportunity to enrich your knowledge through interaction with various eminent personalities from industries and academics. I conclude my address with the following quote: every teacher needs to improve. Every teacher needs to improve, not because they are not good enough, but because they can be even better. By William. With these words, I once again congratulate each and everyone, and thank you everyone to make this program a grand success. Thank you.
Thank you, sir. Thank you so much. Now, I wish to welcome Dr.
Thank you, sir.
Okay.
I wish to welcome Dr. K. Surya
Sharmila ma'am, your mic is muted. Sharmila ma'am, your mic is muted.
Thank you, sir. Thank you so much. I wish to welcome Dr. K. Suryaprabha ma'am to give the summary about the event.
Good morning to one and all present here. It gives me immense pleasure to give an introduction about the STP. The main objectives of the STP are to understand the overview of Industry 4.0 and its benefits to the industry to enhance business excellence, to inculcate different industrial revolutions and automation systems, to introduce the solutions for cybersecurity and machine learning challenges for industrial Internet of Things. The speakers are very knowledgeable and expert in the field of Industry 4.0. I am very much delighted to introduce the eminent speakers of the STP. Engineer Jamil Santiago, University of Technology and Applied Sciences, Salalah, Sultanate of Oman; Gokul Rajendran, Senior Consultant, DevOps UK Public Sector, Newcastle, United Kingdom; Narayan Suresh, Senior Consultant, Flow Solutions, Yokogawa, Bahrain; Dr. Veer Chandra, Space Scientist and Director, Antariksha Research and Development Private Limited, Bihar; Vishal Muralidharan, Senior Sales Engineer, Costco India Limited, Chennai; Dr. V.P. Karthikeyan, University of Technology and Applied Sciences, Muscat, Sultanate of Oman; Engineer S. Gopalan, Senior Control System and Instrumentation Engineer, Blackett Engineering, Qatar; B. Dwarkanath Rao Pawar, Cybersecurity Consultant, TCS, Chennai; Prakash Francis, Senior Software Engineer, Ola Electric Mobility, Bangalore; D. Jawahar, Assistant Project Manager, Tata Motors Limited, Chennai. When we invited them to act as resource persons, they immediately accepted our invitation without any hesitation. They communicated continuously with more kindness regarding the topic, content for presentation and target audience. Really, we wondered and admired about the dedication to share their knowledge with the participants. I am very much proud that more than 200 participants registered for this STP. The participants are from various countries: India, Oman, USA, Brunei and Singapore. Various states of India: Tamil Nadu, Telangana, Puducherry, Punjab and Kerala. The STP will be conducted for 1 week from 23/1/23 to 28/1/23, excluding 26. The formal session will be from 10 to 12 p.m. and afternoon session will be from 2 to 4 p.m. Feedback and assessment will be conducted at the end of each session. Digital certificate will be awarded to active participants. Sometimes we face the problem that the textbooks which we refer become old and outdated. Information shared with the students are relevant to the topic in the curriculum, but not relevant to the current scenario of industry. The first edition in this kind of a thesis, which is an intellectual enrichment for the faculty members, PG students, research scholars and industry persons, which nourishes the mind with the knowledge in Industry 4.0. The STP will be very informative and useful. I request all the participants to attend all the sessions to acquire knowledge in Industry 4.0. Thank you.
Thank you, ma'am. Today's event is indeed remarkable because we have someone who is special here who finds time to be with us despite of his tight schedule from Oman. He is none other than our eminent speaker, Engineer Jamil Santiago. He is presently handling diploma, advanced diploma and BTech courses projects with embedded and IoT systems including machine learning, robotics and automation at University of Technology and Applied Sciences, Salalah, Sultanate of Oman. Previously, he served as Dean and Assistant Professor of CNSC, College of Engineering and Industrial Technology in Philippines. Also, he worked as a site electrical engineer for building construction projects in Doha, Qatar, and worked as a electrical design technical reviewer for building construction projects in Riyadh, Saudi Arabia. I cordially invite Engineer Jamil Santiago to share his thoughts in the topic Internet of Things. I welcome you, sir.
Thank you, madam. I was invited by Dr. Suryaprabha a few days ago, so at first, of course, I was hesitant because I'm thinking, what can I share with the faculty? But I will try my best, so I hope I will meet some of your expectations. Now, I listened to all the talk, and I was especially affected by the words of Dr. Sentin Morgan when he said that, of course, we have to learn that teachers are, it means that the teachers have to improve. Well, yeah, that really resonates with me because every day I'm learning. Every day I try to catch up with so much reading, and of course it's difficult to catch up. I think that the production of knowledge is expanding exponentially, but I will always try. So every day I'm looking at all the new technologies. I try to incorporate it into my work. So that was really insightful for me. Now, for this topic, I chose the topic of Internet of Things because in my work, I'm always using this into all of my projects. So every semester that we are doing the projects, I'm always including this, and I'm trying to include also machine learning and all the other new technologies like artificial intelligence. So I may not be the foremost expert in this, but I can speak from experience about how to do all this Internet of Things. So hopefully I can share all this, some of this knowledge to you. So thank you all for attending this seminar, and of course we are from different countries, so I hope that it's still we can share some experiences. I hope that I'm not the only one who will be sharing the experiences here, so I might also ask you some questions later on in the seminar. So let me start now with my presentation. Is this visible? Good morning to everyone, ladies and gentlemen. Is this slide visible?
No, sir. No, sir.
No, sir.
Maybe the connection is a bit slow. Let's try another one. Is this visible now?
Yeah, visible. Yes, sir. Yes, sir.
Yes, sir. Yes, visible, sir.
Okay, thank you very much. Now, I'm at Salalah, Sultanate of Oman, and last night I have looked up the location of AVCCE College of Engineering, and I found out that there's a distance of 2,834 kilometers separating us. And also, at the time, at 8:30 a.m. in my place, it will be at 10 a.m. at ABC College of Engineering at Tamil Nadu, India. So even though we are separated by this great distance and there is a time difference, thanks to the wonders of modern technology, we are able to share knowledge in real time. For today's topic, I will be discussing Internet of Things, IoT. I chose this topic because of my experience handling so many projects, and always in all those projects I am including the Internet of Things. Now, in the outline of my topic, we have the introduction, the IoT applications, challenges, future of IoT, and we will have a little activity, how to make an IoT device. In most of my talk about technology, I always include a practical part, a workshop, like a workshop for the topic, so that we have something to do. But since we are doing this online, so I will try to go some of the steps of making the projects that I have done before. So it is based on my experience using IoT. Now, what is the Internet of Things? We have here two definitions. Internet of Things involves sensors, the processing ability, the software, and technologies that one can exchange data with networks. But condensing all of these definitions into some keywords, what are the keywords that we can get? Well, first is we must have sensors. But why do we have sensors? So from the sensors, we can get data. So our IoT device must have sensors and it must exchange data, and we do that over networks. So the Internet of Things is not actually the precise term for these devices, because we are not required to connect to the Internet only. We can connect to any other communication networks. So the main thing that we can get from this definition is that we must have sensors, then we must have the data coming from the sensors, and this data must be transmitted over networks. But what is the use of the Internet of Things? So the Internet of Things is not about the device, it's not about the sensor actually, it's about the information. And from this information, what insights, powerful immediate insights that we can get. Because we want to solve some problems. To solve those problems, we have to rely on information. Those information comes from the data sent by the sensors through a communication network. So this is the Internet of Things. Now, how can we formulate an IoT solution? Now, to go at this problem from the top down, we can start with the insights. What insights do we need to get to solve a problem, to understand our business, to understand the industry? So we must start with the insights. So in formulating a solution, we want to start with insights. For example, I need to know which part of my farm needs more water, needs more fertilizer. So that is the insight that I want. How to get this insight? We must have data. So where can we get the data? We must get it through a network of sensors. So from the sensors going to a network that produces this data, and the data is transmitted, and from the data we can do analysis, big data analytics, to gain insights. So this is how I formulate an IoT solution for any of the projects that I have handled. I think first about the insights. What do I need to learn? What insights do I need to get to understand the problem more, to solve some, to offer a solution? So from the insights, I will now write the data that I need to get from the sensors and how to transmit this data to a network. So we can look at it from the top down, or if we are more on the engineering side of things, we can start from the bottom going up. From the bottom going up, what usually happens is that we buy some sensors and we connect it to a device, and only after that we are slowly solving the technical problems going up. The sensors that are needed, the power supply that are needed, the network characteristics, how to connect to a network. Then we get the data, and from the data we will go to analytics to gain some insights. That is, in some way, an easier procedure. So from the top, going down is more difficult than from the sensors going up to the insights, because the bottleneck that I have experienced is from the data. I have a lot of data, but what are the insights that I can get from this? And I want to do it automatically, meaning that artificial intelligence or machine learning should do it for me. So I have some bottlenecks here. So from the data going to insights, I want this to be automated. But since I have a lot of experience in making the projects, usually from the sensors it's easy. So from the sensors, I buy the sensors, then I connect it to a network. From the network, we can get the data. The problem now is how to get the insights from the data. But this is now the overall structure of how to formulate an IoT solution. We can look at it from the top down or from the bottom up. Now I have this graphic that I have when I was searching the internet about the graphics that I can put into the slides. I came across this, and this encapsulates the characteristics of the Internet of Things. So let's start from the top. So the first is anything, any device. So we can use the Internet of Things on anything and any device. So if we look around our room, what are the things that we can connect to the Internet? Actually, if you want to connect anything to the Internet, it's possible. Even passive objects can be connected. So for any device. So when we look around, not just those devices that are with electricity, not just those devices which we are using commonly, even those devices that are passive, that are used once or twice a month, it's okay. So any device can be connected. And we have here anytime, any context. We can use anytime, at night, during the day, during weekends. Any time that we want this device, it can be connected. So, and in any context, it is not just the general Internet of Things. It can also be the industrial Internet of Things, the Internet of Medical Things. There are so many use cases for this, and we can do this for any application. And next here is any place, anywhere. So this is one advantage of Internet of Things, because even if we are far away from a device, the data can reach us. Even if we are in another country, another time zone, it can reach us as long as it is connected to the Internet or to a communication network. Then here we have any path, any network. We can use the cellular networks, we can use Wi-Fi, we can use long-range radio, wide area networks, we can use SIG-V, SIG-FAX, so GSM, so any other network is possible. Then here we have any service and any business. Any service and any business. Industry, medical, commercial, smart grids, smart city, smart buildings, smart home, so it can be used for anything. And here, the most important, it can be used by anyone, anybody. Okay? So the data is democratized according to the setup, and anybody can reach this data. Now, what are the applications of IoT? Now, we will just go through this quickly, because there are so many applications. But most of this we have already used in our projects. The common is for consumer applications. We have a smart home. A smart home, we can automatically control the lighting, the heating, the AC, then the maintenance, security, and cameras. We have a lot of projects involving a smart home and also the smart building. It means that our house is no longer passive. It is now active due to the Internet of Things. The lights will automatically turn on, it will automatically turn off depending on the condition. Then the air conditioning also can automatically turn off depending on the environmental condition and the needs of the human occupants to save energy and to increase the efficiency of our smart home. It can also be connected with the cameras, and of course the usual doorbell, smart doorbells, smart water heaters, smart thermostats. Then for elderly care, we are trying to get into this, but we have the problem of course, ensuring that we have meeting the right health standards, because this is involving the health and safety of people. So for elderly individuals and those with disabilities, what IoT device can we make that will increase the quality of life for these elderly and those with disabilities? Another that we want to try to get into is the Internet of Medical Things. In one of our projects, we are making a kiosk for medical diagnostics. Of course, it's the usual, still ordinary in my view. How to get the blood pressure automatically, temperature, blood oxygen level, all of these initial diagnostics before it goes to the doctor. So this is one of the Internet of Medical Things. This is especially important for hospitals. That's why I want to really get into it, because we can help reduce the burden of nurses and medical doctors. We can improve the utilization of equipment, especially those very expensive equipment, and we can improve the maintenance, and of course the data is also interconnected so that everybody who needs data on this, of course, with regards to privacy and security, can also get the needed data. The main thing is to save lives. And in the transportation part, we have also one project for this, the smart traffic control, smart parking also. So it's difficult to get parking space, especially in big cities. So how can you get this? So in the transportation, all of these are interconnected. And also for logistics. For example, if you buy something from Amazon, they will send you an email that okay, your package is already shipped, and in so many number of days you will get it in your home. So in tracking the parcels and the shipment of products, IoT is already used, and this is in the logistics. Now, another thing is the B2X communication. So far, we have not yet made a project about this, but some lecturers in our university in the IT department have done some projects about this. The part of the vehicle to everything communications. It means that the vehicle, your car is talking to another car, it's talking to the traffic lights, it's talking to the road infrastructure, and it's communicating with the pedestrians so that everything will be efficient and we will not cause accidents. So this is especially important for self-driving cars. So this is really foundation technology for self-driving cars. Now, the building and home automation, we have one project, I think 2 semesters ago. We want to create the smart building. One official of our college wants to implement the smart building. So they have divided the work among several groups. One group will be taking smart lighting, one will be taking up smart AC controls, one will be with smart access control, one will be with the environmental control. So it is divided into different groups. Now, making the IoT device itself is easy. Now, the problem is in aggregating all the data so that we can get the insights that we need. So that really requires a lot of work. Now, this is, for me, speaking about experiences on projects. But if you really want to get it to the next level, you have to go to the commercial solutions. There are many companies offering commercial IoT solutions. Okay, we have Microsoft, we have Amazon, we have Apple. There are so many industrial companies that already have IoT solutions, but of course the expense will be prohibitive for some companies. But the main thing is, it depends on the level of automation and the cost that you're willing to take in terms of IoT. If you want to do this as part of research, as part of projects in the college or in the university, it can be done. But as we go high up into the flow of data, it will be, well, there are some difficulties, but it is not too difficult. Now we have so many technologies that can solve this problem. Now, in the industrial applications, which I believe is the main topic of this faculty development program, we have the industrial Internet of Things. Now, what is the difference with other applications of IoT? Now, the difference is only in the types of devices that are being used, but the main pillars of IoT is the same. The main topics, the main structure of IoT is the same for all of these devices. We will have sensors that will generate the data, and the data will be transmitted to a network, and through this network and the analysis of data, we can get the insights or through analytics. Now, what are the examples? Now, in smart manufacturing, which is, of course, when we think of industrial Internet of Things, we are thinking of manufacturing. Smart manufacturing essentially means that we manufacture a device according to the demand. Previously, before smart manufacturing, we are manufacturing products, even those that are exceeding the inventory, the required inventory. So we are generating waste, we are generating unsold products. Now, in smart manufacturing, whatever is the demand, that is the only demand that we will satisfy with our products. If a customer demands only 1,000 pieces of this product, then that's the only number that will be manufactured. And it will coordinate all of the supply chains needed to assemble them. And also part of this is we have predictive maintenance. Now, in predictive maintenance, we want to predict when a machine is going to fail. And before it fails, we have to do the necessary maintenance or repair so that this machine will not affect the flow of our production. For example, if during the middle of the day a machine breaks down, it will halt the production. So to avoid this, we have to do a predictive maintenance based on IoT devices so that we can take this machine out of production during those times which are convenient. For example, during weekends, during downtimes, okay, so we can get this machine out of the production line and repair it, so without affecting the production and without affecting the safety of the workers, and of course prolonging the lifespan of the device. Now, in agriculture, we have some projects targeting precision agriculture and also automated farming. Now, in precision agriculture, we want to know which area of my land needs this amount of water, which area of my land needs fertilizer. So we are no longer watering everything, putting fertilizer on everything. We want to know which part of my land, of my farm, needs these inputs. So that is precision agriculture. And in automated farming, maybe, of course, we have heard of the vertical farms, hydroponics, aquaponics, aeroponics. So all of these are automated. So there are a lot of Internet of Things devices inside the greenhouse, which monitors water, fertilizer, the pH, the dissolved solids, all of these things, also the light. It controls also the light. So everything will be automated, and it is very clean, and it is organic. So this is in automated farming. We especially need to concentrate on this because the population is growing, and we need to find ways to grow more food in a limited area of land. Then in the maritime, we are monitoring the systems of the boats and yachts, because most of the boats are not used during some period. So we have to monitor whether there is flooding, there is a leak in the battery, then the condition of the boats. So all of these are with the maritime applications of IoT. For infrastructure applications, so far we have not made any devices for bridges, railways, and wind farms. Not yet. For the smart city, also, no, we have not yet made any device for this. But for energy management, we have made some devices, smart meters, and we are researching the smart grid. The most common project will be in environmental monitoring, condition of air, water, soil, wildlife habitats, earthquake. There's so many projects about this. And the sensors are already mature enough to be, and also inexpensive enough to be used in student projects. Now, for the living lab, this is the monitoring of the building spaces and equipments being used by startup companies if they are sharing equipments, so that the government can know what equipments and what processes needed to support these startup companies. So in infrastructure applications in our projects at the Utah Salala, we have made only mostly this environmental monitoring, and also for the students of the IT department, they are mostly their projects are about this. Now for the military applications, we have made one project that was presented to the army, but it is a robot, but it is also doing environmental monitoring. So we have not yet made actually projects for the military, but we have entered a project that is using a robot for environmental monitoring and this is disinfection. So in all of this, the principle is still the same. Sensors, data, and network. And after that, we have the analytics. Now for the product digitalization, the Internet of Packaging, this is actually passive. So when we go to a grocery, we buy some products with a QR code, with a barcode. So this will be connected to the inventory. It will be connected to the forecasting and connected to the supply chain controls. So we will have the Internet of Packaging. Now, what are the challenges in IoT? Now, I know that the next speakers will be talking about this because this is an important topic, especially for the industrial Internet of Things. Number one is security. I was asked this question in one of my lectures in IoT for students. Now, the answer is, it depends on the device. Some devices that we can buy for IoT are lacking in security features, but some have really, I will not say it's foolproof, but at least they have considered all the standards required for IoT devices. One requirement is that if you are a manufacturer that will make this IoT device, it must have security feature so that the data will be secure and you know that it will not be tampered with. So in the security area, we have to make sure that the device contains some cryptographic chips and the device will not be hacked easily. Because if it can be done, it will imagine thousands of IoT devices whose security is compromised and being used to perform a denial of service attack on a website or on a country's infrastructure or on the power plants. So this is a big area of this IoT. So it is actually one of the biggest. I'd say it will be the biggest challenge in IoT because as you produce millions of these devices, one weak point of this can propagate to the other devices. So this will have to be really strengthened by the companies. Next is we have the privacy. if your Roomba, the Roomba is the robot for cleaning. It was reported a few months ago. A Roomba has taken pictures of the occupants. Okay, so, and it was shared to the internet. So that is an invasion of privacy. Now, if we have a lot of IoT devices in our homes, in our industries, in our schools, this is a big concern that your privacy will be invaded because data about you was made known to other people without your consent. Even a simple device such as a doorbell can be made to invade your privacy. Smart meters can also be made to invade your privacy. For example, in a smart meter, it knows when the lights, when the energy consumption of your house goes down, when it goes up. So if somebody has this data, they can predict that, oh, you're out of your house. Oh, there are so many people in this house. During this time, during this day, people are in this house. But during these times, there are no persons are there. So they can now attack your home based on this leak of information, and it is compromising your privacy. Yeah, the next challenge will be data storage. We have millions, actually it will be billions of IoT devices. How can we store this so much data coming from billions of devices? One solution that was proposed is to get the data into the device itself. It will not be transmitted to the internet or to the network. The analysis of the data will be in the device itself. So this is called edge computing. The only thing that will be transmitted by the device will be the analytics, the analysis of the data. So, but the bulk, much of the data will remain with the device. Next, another problem is scalability. When we were making the IoT devices for the smart building of our university, one problem that came to mind is scalability. Of course, we can experiment with this. We can teach the students how to make 1 or 2 or 3 devices, but how to scale all of this to the whole campus of the university. We have so many rooms. They want to automate all the rooms. Well, anyway, most of the rooms. So how can we scale the construction of 1 or 2 devices for one small student project? And how can we make so many of this? Well, of course, the first thing that comes to mind will be the cost. But other than the cost will be the installation, the production, the installation, the maintenance, and the operation of this. So this is one big problem. So for an educational institution that is researching IoT, it is a lot easier if we will just concentrate with a few devices, make it add more features and make it really operational. But after making this sample batch of products, the next thing will be scalability. What if I want my IoT device that controls the light, that monitors temperature, monitors the number of persons inside the classroom? How can I implement this to all of the classrooms in the college or university? And how to get the data, how to perform the analytics. So this is a really big problem. Now, one solution, of course, is to go to the commercial companies who already have the IoT solutions. Now, when you go for the commercial companies, of course, there will be licensing, there will be a lot of cost, there will be training, but it is one solution if we really want to do it university-wide or college-wide IoT devices. Now, the other problem is interoperability. Now, in interoperability, some of my devices need special programming to interact with another device because they are from different manufacturers. For example, usually I'm using Arduino. There is also ESP32, ESP8266, and different boards, different sensors. So there's a question of interoperability. Now, the next is reliability. Now, in the reliability, well, it depends on the quality of the sensors, the quality of the processors, of course, the connections, the gateways. So This is also part of IoT. Then the last is the technical standards. Now, the IoT devices that we have made so far don't follow an established standard because it is not yet made by the companies. So different companies have different standards. They may be proprietary. So there is a vendor lock-in. Now what we want is for these things to be open source. As much as possible, we want it open source so that we can plug and play. So we can construct a device, then plug it into the network, and it will give the same data as before. Now, in the standards, the usual will be the data standards, because we are aggregating data from thousands and millions of devices. There must be a standard for the transmission, the storage, and operation on data, so that even though it comes from different devices, the data will be formatted in the same way. Okay, now what is the future of IoT? Now, what I want to leave with you is how to conceptually think of an IoT device, so that in our schools, in our universities and colleges, we can make IoT devices because we already have the structure in our mind, and the next problem will just be, where can I get this device? How will I connect this? How will I process the data? How will I share it to a network? And how will I maintain it, and how to use other technologies on it, like machine learning and artificial intelligence. Now, for this slide, I will show you how I usually go about conceptualizing an IoT, in addition to the top-down or bottom-up procedure. For example, I have a fan. This will be an actuator. This is the common scenario. An actuator, a fan, a water heater, a thermostat, a motor, a farm equipment, a cultivator, any device. Usually it actuates, it gives heat, it gives motion, it gives sound. So this will be the actuators. Now, this is of course not yet an internet connected device. What it needs is a sensor. So the actuator, which is a fan, we will put a sensor on it, a thermometer, and we combine them together to make sensor and actuator, which is a temperature controlled fan. So think about all the devices that we have around us. So even inside our room, what are the devices that is only an actuator? It has no sensor. The light is only an actuator, it has no sensor. My water heater is only an actuator, it has no sensor. Well, it has a water sensor, it has a temperature sensor, but usually it is a very simple sensor. So any device that we have in our house, most of them are actuators. Now, if we connect a sensor, we can now have a combination, a sensor and actuator combination. In this example, we have a temperature-controlled fan. Now, what is next? Now, from the slides that I have shown you about how to conceptualize an IoT device, and in this slide and another slide, hopefully I can share with you how I make an IoT device. Because later on, a few slides from now, we will go to an exercise of how to make an IoT device. So we will do a little reflection about how to go about this, so that even after I finish this lecture, so hopefully you have learned something from me. It's in a small way, I have shared something with you. Now, what will come next after the sensor and actuator combination? The next will be, we add the processing ability. Now, for the processing ability, it means that the speed of the fan will change based on different temperature levels. So the behavior of the actuator is changing based on the values, based on the data from the sensor. Are we in the IoT device yet? not yet. It's not yet an IoT device, but we have now increased the intelligence of our actuator. We have actuator, we added some sensor, we combine them together, and another is we will combine with processing ability. In the processing ability, this now comes with software or some programming or some electronic circuit that will do this requirement to adjust the fan speeds based on different temperature levels. Okay. Now, after this, we have to connect to a network. So when we connect to a network, we can now exchange the data with other devices and systems. For example, when it is very hot, the fan will turn on, it will adjust its speed, and what will happen? It can also be connected to the network containing the controlling the air conditioning system. So the air conditioning will maybe turn on for a few minutes. So the data from this device is now exchanged with another device. And we can see the data from our mobile phone, we can see the data from our computer or on any device anywhere in the world, anytime. So what we can see here is this is now an IoT device. So all of this, so we have the actuator, we have the sensor, we combine the sensor and actuator, we have the processing ability, and we connect it to a network. So up to this is now an IoT device. Okay? Now, what is the future of IoT? Now, I'm always reading, I'm always studying every day. I'm always looking how to improve our projects. Now, it's already an IoT project, but how to get there? Now, the next thing will be artificial intelligence and machine learning. So I think that is the future of IoT, especially now that we have ChatGPT. ChatGPT is an artificial intelligence bot which can answer your questions and do programming code. So this is the future of IoT. Put more intelligence into it, put more autonomous control, okay? And another development will be the addition of the ability to learn. It can learn from the data. It is doing machine learning on the data. For example, you have a data from 2000, from the year 2000. So all of this data will be used by the machine, will be used by the IoT device to learn about the data, and it can better control its behavior and better share its data to other devices because it has the ability to learn. And it is not just the ability to learn, because every device has a limit. Everything has a limit. There is no device that have infinite capacity, that is unlimited speed. So everything has a limit. So when a device reaches that limit, it needs to cooperate and coordinate with other devices. So imagine all of these IoT devices are communicating with each other, coordinating. What will be the result? For example, if we have a smart city and all the IoT devices are coordinating with each other, what we expect is that when we go from one part of the city to the other, our experience will be much better. There will be less traffic. It will be more convenient. It is more efficient for us for the simple task of going from one place to another place, because we are helped by all of these IoT devices. And it is connected to our, say, mobile phone, to our computer, so we can get the data anytime, anywhere. And the data will always be updated. And it is presented to us in the most convenient way possible. Okay? And we will go to another example of this. So up to this slide, I hope what we have retained is that to make an IoT device, we need an actuator, the sensor, and all of this must produce data. The data as a result of our processing ability, this data will be transmitted to a network. And the future of IoT will be to put more intelligence, autonomous control, learning through machine learning, and coordination with other devices. And the last will be coordination with artificial intelligence, which we will discuss a few slides from here. So to summarize from the beginning of my talk up to here, we have the insights. From the insights, insights coming from the data, from a network, from the sensors. Okay? But to make a more complete IoT device, we have the actuator, the sensor, processing ability, network, and of course intelligence. Now, can we remove the actuator? Can we remove the actuator? Is it still an IoT device? Well, the answer is yes. If we don't need the actuator and we need only the sensor, that is still an IoT device. So we remove this. We get only the sensor. In this case, we have the thermometer. We have the temperature. The temperature is processed, and the temperature data is sent to a network. What shall we do with the temperature data? We can add intelligence, control, ability to learn, coordination with other AI. So it is still an IoT device. Now, we can remove the actuator, but can we remove the sensor? Now, it is, if we remove the sensor, then where is the data? Okay, so the essence is our IoT device must always produce data. It's only the data from the data that we can get an understanding. We can get information, we can get the insight. So we must have the sensor. Okay. Now, we already have this framework from which to think about IoT. This can be applied to any area. Manufacturing, which is of course the industrial Internet of Things, which is the main topic of this week-long seminar. We have the medical things, we have the smart city, we have the commercial applications. So all of this will revolve around these main concepts: the sensors, the data, the network, and the future will be intelligence. Most of this will be intelligence and coordination with other intelligent devices. Now, in our projects, now this is a digression and an overview of the practical side of the projects that we are doing at Salalah, Sultanate of Oman, at Utah Salalah. We are using mostly this device, Arduino Nano 33 IoT, but we can also use other devices. For us, it is convenient because here, this is designed specifically for Internet of Things. We have the Wi-Fi module, we have the processor, and we have the cryptographic chip for securing our data. We have accelerometer and the gyroscope here. We can add so many sensors, we can add actuators. So this is a complete solution for us. We don't have to connect another device to get some features. But the main problem with this is we have to buy it from outside Oman. We don't have the supply inside Oman. So the last time we have purchased this from Amazon, it took several weeks to arrive at Oman. And well, it is a bit expensive than the other devices. Now it is operating at 3.3 volts. The current is very small, but we have these specifications. Now, from the time we have considered IoT, this is the device that we have consistently used. So far, we are not using the other devices, but of course, that is also convenient for us if we have the different types of devices, so we can learn more about these other microcontrollers. Now, these are the devices, the components of this Arduino Nano 33 IoT. We have the Wi-Fi and Bluetooth, so we can connect to our mobile phone through Bluetooth or Wi-Fi. We have the cryptographic chip. Now, we are depending on this to make our data secure. So we don't have to worry about this, so it is already automatic. Then we have the microcontroller itself. Then the accelerometer and gyroscope. This one we have used in our another project. Last week we have used this specifically to solve one problem we presented to us by a company. A company is affiliated with the government. It's actually it's a company owned by the government. Asked researchers, students, to come up with a solution about the waste problem. The waste problem, especially the big waste. So we have proposed a solution based on this accelerometer. Hopefully we will get some results maybe later today, because they are already, my group of students are in Moscow to present their project. So we have used this device. We have used this device as an Internet of Things device using this accelerometer, and we have added long-range radio. The long-range radio, according to the specifications, can reach up to 2 kilometers, even more if we have the line of sight and without any obstruction. So that is one solution that we have presented. So this is using Internet of Things in a network, but without depending on Wi-Fi. It is using long-range radio. But of course, there are other solutions. But I'm just sharing with you what we have done for the projects that we have completed last week and the other semesters. Now, this is also part of a digression, an added topic. This is not in the main topic that I'm supposed to discuss with you today. This is how to use the Arduino IoT Cloud. Most of our projects are using this now because, as you know, Arduino is very easy to use. We can teach this to students and they will catch up a lot quicker. Now, we have used the Arduino IoT Cloud to produce IoT devices. The IoT devices are connected through Wi-Fi and it will be connected to the cloud, the Arduino IoT Cloud. Now, using this Arduino IoT Cloud, we can see the data and we can control the device from anywhere in the world. I have already tested this and I am very satisfied with this. But there are many other solutions for the IoT Cloud. But of course, we want to have something that is free. Of course, there are commercial options, but we want something that is free and easy to use, and we have a lot of resources to learn from. So the free portion of this this IoT Cloud is this. For the free account, we have two things: unlimited dashboards, 1 day retention, 25 per day. Then we have machine learning tools. Previously, I am using this entry 10 things, and it is very cheap, only almost $2 per month. What I like about this is we have the over-the-air updates, and next is we have the machine learning tools. Now, over-the-air updates means that even if the device is already far away from us, we can still change its programming. So from my computer, I will change the program. My computer is connected to a Wi-Fi network. The device is also connected to the internet or to another Wi-Fi network. So from my computer, I can change the program, the behavior of my IoT device, even if it's in another country. Thousands of kilometers from me, I can change its programming. So that is over-the-air updates. Now, what is, if we are including IoT in all of our student projects or research projects, whatever that is, this is one feature that we want to try, because imagine if we are implementing smart building for the campus. We have so many IoT devices in the campus. What if we want to change the programming? We don't have to go to each device and physically connect a USB cable to change this programming. We can just change the program for all of these devices wirelessly and wherever we are. Okay? So I just want to share this with you, but you might find it useful. Actually, I want to ask you what you want to learn from me, what other devices, software that you want me to share with you, because I have no idea really how can I satisfy your curiosity? How can I meet your expectations? Because, and also, how can I also learn from you? For example, you can tell me, oh, we are using this software, we are using this device, and I will say, okay, I will also try that device because I have not used it before. So this slide is my way of sharing a little of how we go through making our projects. So we are using the cloud. It's all easy to use. From this, we can get the dashboard. The dashboard is a graphical interface that we can see from our mobile phone or from our computer to see what is happening with that device, even if it is in another country, in another time zone. So we can control that. Here in this example slide, we can turn off the switch. We can turn off the light, we can turn it on, and we can see the light level, maybe temperature, humidity, pressure, vibration on that device. The next is also we can get the data, but then if you want, you can install the remote control to your mobile phone, and from there you can get the dashboard. You can see everything that is happening with the device. Okay. Now here we will pause for maybe 1 minute to let us think about this question. How can we make this stethoscope into an IoT device? Now, this is a problem, an exercise problem for us about how to think of making an IoT device. Now, we know that an IoT device must have sensor. From the sensor, it will generate the data. There might be some processing, but it can be processed later. Then we have to connect it to a network. So we have sensor, data, network. Now, how can we apply this basic structure into this device, and can we add something more? Can we make it more advanced? Now, my purpose in showing you this is so that we can together, it's not just me, you also can suggest ideas how to make this better. So how can we make this as advanced as possible? Maybe I want to hear from you, your ideas. How can we make this as advanced as possible? Better than the state of the art now in 2023, how can we make this better? Whatever the state of the art this year, how can we make this device better?
In the client side, we can have the sensor to read the heartbeat.
Yes, ma'am.
Maybe it may be connected with some Wi-Fi with the mobile phone.
Yes, ma'am. So with Wi-Fi and mobile phone, with sensors.
So by which the heartbeat can be read from the server end or the cloud end.
Yes, from the cloud end. Yes, ma'am. Correct. Yes. Well, yes, that is some of the features that we can add to this. Okay, so where did we start? The sensor. Okay, so we start with the sensor. Now, this is not an electronic sensor. It is the traditional sensor, sound sensor. Okay, so this one, how can we make this an IoT device? Other suggestions are very much welcome. So this device we will replace with another sensor. We will make it electronic. Okay. So if it is now electronic, we can get the data. We can connect it to a mobile phone. We can connect through Wi-Fi, and from the Wi-Fi connection, we can send it to the cloud. Okay, so that is already an IoT device. Yes. What can you add more? Actually, there are so many things that we can add to this. Of course, that will be a bit technical, and you must have some background knowledge about how this works. But there are so many things that can be done with this. Okay, let's start with the sensor. Now, the sensor, this is the stethoscope. The sensor listens to the sound from our chest, from our heart. So it listens to the heartbeat. The doctor will have to listen to the sound. It will go like dug, 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 dug. So from those sounds, the variation in the sound intensity and the spacing, the timing, the doctor will make some conclusion about, okay, your heart is beating irregularly like this. You may be having arrhythmia or some other condition. Your chest is sounds like this. You might have some obstruction in your lungs. So how can we improve on all of this? Okay, let me. Any other suggestions is very much welcome. You can interrupt me if you want. Yeah, please interrupt me. So what we can do is we change the sensor with an electronic sensor. This will be like a microphone because this listens to sound, so we can put a microphone here. Okay, that will be electronic. Now the sound will be with a certain frequency, but using a microphone, an electronic microphone, we can increase the frequency range. We can make it from very low sounds, boom, 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 then to the high sound. So we can increase the range of the sound detected by this device. Okay. Another is we can reduce the noise. So even if it is noisy, we can clean up this signal and get only the most important part of the signal. So that cannot be done by this device. This is not yet an IoT device. It's not even electronic. So by using electronics, we can expand the range of frequency. We can remove the noise. We can detect only the signal of interest. Then we can enhance the signal. Some signals may be very weak. Some may be very, very loud. So by using compensation, sound compensation, or signal compensation, we can make the weak sounds louder. We can make the loud sounds weaker. Okay? So that the overall, the signal quality will be very good. Okay, so that is about this sensor. Now, what other things? After that, we transmit the signal. Instead of using this hollow tube filled with air, we can replace this with a cable, the electronics, the wiring, and we will now, at the earpiece, we can replace the earpiece with electronic speakers. The speakers will be here. Okay. And the sound will be better. Now, is that all we can do? We can do so much more. Okay, I will now give some suggestions about this. Instead of producing sound, can we produce a picture, a waveform, a moving waveform of the sound wave? We can connect this to a waveform display. Okay? We can transmit the data and we can see from our mobile phone the waveforms produced by this device. Okay? So that is one improvement. Then another one is, can we save the data? Can we record the data? So this one is not recording the data. If the doctor examined me with this device, after a few minutes, maybe he will forget the data. Okay? But if he will use the modern stethoscope, once he examined me, he will save the data. 1 month from now, we still have the data. Okay? So we are saving the information. We are saving the data, and we have a visual representation of the data, not just hearing it from this earpiece. We can see the actual shape of the wave. And the wave will be clear. It is not noisy. It is enhanced. Okay? So the doctor will be saving the data. Then another, he will examine me a few weeks from now. He will get another set of data. And this data can be compared. It can be compared with the other set of data taken several months ago. So now he can compare the data and see what is happening over time. Now, that is not possible with this device. Okay? But by making it to an IoT device, we can do so much more. So you see, this is a thinking exercise for us. how to make an ordinary device into an IoT device. Then in the next slide, we will do a little more similar to this. Now, that is not yet finished. What else can we do? Okay, so we have made it electronic. We can transmit the data to our phone. We can record the data. We can enhance the data. We can compare it with previous data. And since we can record the data, what will happen? This is a recording made of my condition. This device can also be used to make a recording of other people. So the doctor is studying all the people, all the heart conditions, all the lung conditions. He can make a database, a library of all these signals. You see what I'm getting at? Now we have big data. So from this simple device, once we make this into an IoT device, we can now go to big data. All the students in the college, all the people in my town, we can now have this data, and the doctor can now make a comparison between this person and that person, and how can the doctor make a better diagnosis? Okay? But it is not yet finished. It is not yet finished. What remains next? What remains is, since we have now a lot of data coming from an IoT device, we can now apply big data analytics. We can apply machine learning algorithms on this data so that the doctor will make a more informed, a more complete, a more comprehensive diagnosis of our condition. So in the end, it will help the doctor so that they can help us improve our health and maintain our health. Is it enough? Actually, there's another one. From this data, we can now apply artificial intelligence. The artificial intelligence algorithm will say, from this sound coming from this person, the machine will say, okay, there's a 85% probability or 90% probability that this person has this condition, has this lung condition. There's a 90% probability that this person, based on this data, has this heart condition. So the artificial intelligence will now be assisting the doctor to make an informed decision. Okay? So the artificial intelligence is now an assistant to the doctor. So what have we learned from this? Any device can be made into an IoT device, and once we get the data, we can enhance the data, we can expand its range, we can record it, we can make a database of this data, we can pass it through machine learning algorithms, and we can feed it through artificial intelligence. And the artificial intelligence will say, this is the condition, this is the probability that this is the condition. Okay? You see how powerful that is? This is now 2023, last November 30, OpenAI released the chatbot called ChatGPT. And that chatbot, that artificial intelligence network, can now be connected to this device. You see, we are now actually on an inflection point in the use of IoT devices connected to artificial intelligence. And it is still very early. It is just last November. November 30, December 30, we are not yet 2 months after the release of the ChatGPT. So I encourage you all to think about this. How can our projects be taken from simple student projects to research projects to commercial projects to industrial projects to make it widespread? It's a global, we can make it a global application assisted by artificial intelligence. So you can see we are expanding our minds from a simple non-electronic device. We make this electronic, We set the data, we connect it to a network, we can get the data from any device in the network, anytime, anywhere. From this, we have big data. From the big data, we have machine learning and artificial intelligence systems. You see, is that the very best that we can do? Actually, there is one thing that we can add to this, but actually up to now, it's already, mind-blowing. If we can make this as a research project, okay, any device in our school, in our community, in our city, in our state, can we go through that device and layer by layer, add more features, expand the capabilities of this, and lastly, connect it to artificial intelligence? And that is really, I think you can make a lot of companies, you can make several businesses, a lot of businesses out of this. Okay, so I hope I have expanded our understanding. Actually, I have just thinking about this, I have already improved myself. Hopefully, it will also improve how we think about IoT. Now, let's go to another. Actually, it's not finished. So this is the stethoscope. Okay, we have the different parts of the stethoscope. Each part can be improved. The bell can be made electronic. So this can be made electronic. This will do the wiring. This can be electronic. So everything will be electronic because we need the data electronically that can be sent efficiently, almost instantaneously to anywhere. Okay, and through the internet or to any communication network. And we can view the data on any device in any format that we want. We want sound, it's okay. We want graphical visualization, okay, it's good. You want it to be transmitted electromagnetically, yeah, it's okay. So whatever modality that we want, it can be done. Now, the next thing, there is one more thing with this stethoscope. The next thing will be this one. Now, what is this? What is this device? Now, this is a 3D printed stethoscope. 3D printed. How to make this? To make this device, all you need is a 3D printer and the plan, the plan of how to make this. And it will be transmitted to the printer electronically. So what does this mean? This will be the end of our slide for this stethoscope. So our device is already so advanced, so far advanced, connected to artificial intelligence. But we live in a country with no other infrastructure for making a stethoscope. We don't have a factory for a stethoscope. We don't have the metal. Okay, maybe we don't have the electronics. That will be a big drawback. But suppose we have the electronics, but the problem is we don't have the technology, the plan for making this. What we can do as a final feature of this slide on the stethoscope is to make it available, to make it possible to 3D print this device. Now, of course, this device is only made of plastic, but hopefully later on we can 3D print in conjunction with this also the electronic devices. Now that will be a bit more advanced than what we have discussed so far. So this is 3D printing. This was made by a doctor, I think it is in Gaza. So there is no way for him to get some stethoscopes, but he can connect to the internet. So what he did is he made a plan for 3D printing this, and only using the knowledge, the information passed through the internet, he fed the information into the 3D printer and he was able to make it. So even if we are in a remote island, a remote location, we can still do something if we have a 3D printer, as long as we have some way of getting the information, so we can still make our own device. Okay? So this is added feature for our exercise on how to make this stethoscope in an IoT device. If you think this is already, it's a great exercise, now I want to show you another. how can we make these two-way radios into IoT devices? Now, what I want to share with you is how can somebody, some company think of these things that is, well, it's a bit, it's advanced. I have to consider that it's really advanced, but how did they go into thinking about this thing? And we will do the same thing. Any suggestion? How can we make these two-way radios into IoT devices? This is a bit less obvious than the previous stethoscope, but let's try our best. Actually, this is already a commercial product, but I want to go through this process with you so that we can learn together. Any suggestion? It's 10:30. Okay. This is a bit less obvious. So how shall we go about this? Now, remember that in our discussion, the IoT device must have sensor. From the sensor, we can get the data. From the data, we can transfer it to a network. And from the network, we can get the data to do so many things. We can perform more analysis, more analytics, and use the data to start other processes. How can we do these things to this simple radio? Now, this is the common radios. Let's think of this as the oldest version of the radio. Let's say this is the oldest version of the radio. Maybe it is obsolete. This one is also new. You can see it has a graphical user interface. It can connect to a map. It has a compass. It can search. Maybe there's a Google browser inside, internet browser inside. But how can we make this into IoT devices? Now, the first question will be, what is the sensor? What is the sensor that we need to put into this? Well, we know already that we are using the radio to talk. We are talking into a radio. We are using our voice to send a signal. And we are expecting that we can hear a signal in the form also of audio, which we can interpret. So, audio in and audio out. Audio in and audio out. How can we make this into an IoT device? That is the main thing. Okay, let's put it here. So audio in and audio out. How can we make this into an IoT device? Now, this is also an exercise for us to think about really expanding our knowledge, our skills of how to make an IoT device. When I read about this, I was surprised. Really, they were able to make this. Okay, now the solution is this. I will now go into the solution. The solution is to convert voice into an electronic signal. Okay, so the voice will be the voice will go into here. It will be converted into an electronic signal. Of course, we know that this radio converts that into an electronic signal. And it will be transmitted. We will receive a reply, also an electronic signal. It will be converted to voice by the speaker. But to make this into an IoT device, what we need to do is to put artificial intelligence inside, to put machine learning inside this. Now, also this. Now, what will happen if we do that? Suppose you are speaking in, suppose you're speaking in English here. You talk in English, your your friend is speaking Arabic. When the signal reaches to him or her, this will be converted to Arabic. So English in, Arabic out. But it will be processed on this other device. Okay, so your signal here will be English, the output will be English, but when it reaches his or her device, it will be translated into Arabic. Now, if we have different languages in use among our team members, it is not a problem. We can set this. I speak here in my language, you will hear it in your language. The other person will be speaking in his or her own language, and we will receive it here in English. This was already done. This is already a commercial product. So you can see from this concept alone, how mind-blowing that is. That is so advanced. You speak one language here. Your other person who is speaking another language will not understand you in English, but he's speaking, let's say, Arabic. So he will understand Arabic here. He will speak in Arabic here, and when it reaches this region, you can hear it in English. How cool is that, really? Is that enough? Actually, it's not yet enough. It's not as advanced. It's pretty advanced, but we can add more. Another thing is, this radio can be made into an IoT device that understands so many languages, and it also has the artificial intelligence necessary to start a workflow. What do I mean by that? Suppose you're in the field. Actually, this device was designed for field workers. You are at the field. You don't have your paper. You don't have pen. You're only talking to this radio. We are called a deskless worker. We are not sitting on the desk. We are not handling a paper and pen. We are not handling a computer. What we have is only this radio. But still, we can do a lot of work. Why? Because this radio will record our voice, will record our instruction, translate it to different languages, and in addition, just by speaking code words, we can initiate a process. For example, this is being used by a healthcare professional. Then, when the ambulance arrives at the hospital, he or she doesn't have to write anything. He will just talk on the radio and say, okay, this is, I hear usually, okay, this is code blue. Oh, that is the easiest word that I can say now. Code blue. So the artificial intelligence inside this radio will detect the signal for code blue. And this radio will initiate a workflow. Going to the hospital, it will initiate the code blue protocol. So inside the hospital, the different devices there will now prepare, for example, the emergency room, the different machines needed to this, alert the nurses, alert the doctors, just by speaking a code word into this device. So you can see, by using artificial intelligence, you can program different code words here, which by just speaking the code word, you can now initiate a workflow, right? Automatically and in real time, immediately, without waiting for several minutes of delay. So that is really an advanced feature of this radio. And of course, it is recorded, so you can see who said what, at what time, where. This also has a GPS, so you can coordinate the different team members wherever they are. They can still do a lot of things. They are coordinated through radio that understands their language and can initiate workflow just by using code words. So every time we see somebody speaking into a radio, what are we thinking? Okay, how many minutes does it take for this person to respond? What if there's no one to respond to his call? What will happen? Okay, that is already a solution incorporated into this radio. What if you're talking to a radio and there's nobody listening to this other device? This other device will have call forwarding, or if you call a code word, it will do some things by itself. And this radio autonomously by itself can respond without waiting for the person to be at for example, a bus dispatcher. So, for example, this radio is in the bus dispatcher's office, and this is in the driver's hand. So the driver is speaking to this. Even if the dispatcher is not there, this radio can respond. So what have we added to this to enable this kind of operation? We have added artificial intelligence. What will happen if we add ChatGPT in all of these radios? Well, the ChatGPT algorithm can respond intelligently to our request, supply us with the information. Okay? If you are in a big mall, you ask the salesperson, what is the price of this item? Okay? The salesperson will just talk to his radio. It's like, okay, what is the price of this item? That code word will interface to a database of prices, and the machine will send back the price using voice without writing anything, without pressing any button on your mobile phone. Okay? So through voice only. Think of the possibilities. We are in an area. We went to another area. We don't know the language. Just by speaking into this device, we can understand each other, and we can get things done automatically and easily. So that is the power of Internet Things of devices that are integrated with artificial intelligence. And do not think that this is science fiction. It is already a commercial product. It is being sold to companies who have a lot of deskless workers. There's no need to have pen and paper. Okay? No need for pen and paper. You are just talking. Everything is recorded. Whatever you want, it will be sent to you through voice or text or a visual or a map. Okay. So because all of these are internet connected devices. Okay, I hope I have expanded our knowledge of these devices and how to really add more features into this. Now, the last device, this one. How about this? Now, this is now the topic of this week-long seminar, the industrial Internet of Things. What can we say about this? There are a lot of robots in there. So how many robots? So 1, 2, 3, 4, 5, 6. Okay, let's say more than 10. Okay, so this is a complicated operation. This is now an example of the Internet of Things as applied to industry. So we will now call this the industrial Internet of Things. And of course, the topic of the seminar is Industry 4.0. So in Industry 4.0, why is it called the Industry 4.0? Because we are now putting smart machines, smart factories, Internet of Things, cloud computing, artificial intelligence, machine learning. We have edge computing, cybersecurity, and we have digital twins. Now, how can we incorporate Internet of Things into this setup? Now, to guide us, I have placed here one question. If something happens in this facility, will we be able to determine the source of the problem and correct the situation easily and efficiently? There is a problem. The production of cars is stopped. Why? Where is the problem? In the robot? In the conveyor belt? In the assisting systems? In the welder? In the riveter? In those robots that do specialized jobs? Where? Where is the problem? Now, by using Internet of Things, and it is connected to each and everything of all these devices, we can have the data that will guide us into looking at the problem and solving it. Now, of course, you will say that, oh, there's a lot of robots in there. And if we put a lot of IoT devices, we will be deluged with data. We will have so much data that we don't know what to do with. We don't have to do this manually. everything will pass through a machine learning algorithm, and it will be presented to us graphically in the most convenient way possible, so that we can remove the clutter of all this data. We will just go directly to the possible problem and the possible solution. So you see, so we can see here that in the Internet of Things, we are going to big data, but we don't have to do this manually. This can be done by machines, and the output of the machine learning algorithms can be presented to us in a convenient way using artificial intelligence like ChatGPT. So in industrial IoT, these are the three things that we want to have information about. One is the predictive quality. Do we know that we are operating at optimum quality, or some improvements can still be done to increase the quality? Are the machines operating at optimum quality? Can we measure the quality being produced by all of these machines? So by using industrial IoT, we can have some figure. Okay, this one is operating at only 90% quality. By doing this, we can improve it to 95, 98, or 99, or 99% quality. And another is asset condition monitoring. Is this robot being used 90% of the time, or the other robot is being used only 85% of the time? So we can now compare the different robots to see, of course, this has more performance, so we have to be more careful that this does not break down during the course of production. And that will lead us to predictive maintenance. You see here, if we can see here that if something breaks down in this assembly line, one robot breaks down, it has the potential to halt all the other robots in this assembly line. So before that happens, we want to know if this robot needs maintenance, needs repair, needs to be taken out of the assembly line. What will happen if this will break down in the middle of production? Maybe it will damage the product, maybe it will compromise worker safety, and of course it will reduce the lifespan of this robot. But by using industrial IoT, by putting internet connected devices here with the sensors, we can get data that will tell us, oh, the vibration is increasing. Last week the vibration is only this much, now the vibration is bigger and it is more frequent. So from this data, from the change in data, from the baseline, we can see that this robot needs to be taken off the assembly line for inspection, but we can do this during weekends, during the downtime hours. So it will not affect the production, and it will not affect our workers and the quality of the machines. So these three use cases of industrial IoT are the most common. So predictive quality, knowing if we are producing at the required quality, the machines are operating in their optimal condition, and do we know when these machines are going to break down? Preemptively, we have to take them out of the assembly line so we can inspect, so that they will not break down in the middle of the production. Okay, now so in industrial IoT, this is an expansion of our topic of industrial IoT. We can connect and monitor all manufacturing equipment, any age, any model, to the IoT, industrial IoT network. This is a challenge because some machines may be very old, but still an IoT device can be connected to it that will inform us how it is performing, or does it need maintenance. So any age, any model can be connected. And once we have this sensor, data, network, we can feed it to machine learning. We can record everything. We can record, measure performance. We have the cycle time. You can see in this graphic, which I have taken from this company. We can record the cycle time. So you can see the chart here. The different machines are here. And when it is being used, what machine is being used most of the time, which machines are being used in a less amount of time and only periodically. So we have a record of cycle time, the uptime, the downtime in minutes, and the percentage of utilization. Okay? So using this data that is presented to us graphically with numbers and percentages, so another advantage would be we can decrease the unplanned downtime and increase productivity. So in industrial IoT, we are bringing together machine data and analytics. Okay, I think I will conclude here. Thank you for listening. We will now go into some questions if you have.
Thank you, Dr. Jameen Santiago, sir, for your wonderful and valuable speech. The session was very interactive, sir. Shall we ask the participants if they have any queries, sir?
Yes, ma'am.
Dear participants, if you have any queries, you may clarify now.
Sir, I do have a query related to IoT, sir. Considering IoT, embedded sensing capabilities are playing a vital role in new technologies and devices. While coming to security and privacy, they are interconnected. Security may exist without the privacy, but privacy cannot exist without the security. Can you suggest some ML algorithms to improvise it in, machine learning?
Okay. I think it's my opinion on that. Now, the security and privacy itself should start from the hardware level. In my opinion, we should not start with the machine learning level, because the data should always be at the hardware level. Because if we can hack into the hardware level, all the upstream flow will also be affected. So, but of course, we can say that once we have secured this device at the hardware level, the next will also be to secure it at the software level, and we can add the machine learning system. Now, the problem with that is that the data is already out. The data is already out into the network, and the network was already compromised. In the machine learning level itself, the thing that we can now do is to look at the irregularities in the data. Now, for that, okay, you're asking for machine learning algorithms. Well, I have known only CNN and autoregressive, because we are doing a project for a power company, and we want to present them a solution using machine learning. But for the security aspect of this, I am sorry that I cannot suggest the machine learning algorithm for security. But my opinion is the hardware itself should be secured at the very start, because because of this, there is a standard, and it requires all manufacturers of IoT devices to secure. There must be a security system in the product itself, starting from the product. So when you buy something, there must be already a cryptographic chip there that will store your credentials, and it will not. It will secure your data, so it will not go out. It will not be hacked by unauthorized systems.
Thank you. Thank you, sir.
Any other participants who have any doubts? Sir, shall we conclude, sir?
Okay, what is meant by Industry 4.0? I have researched this. Okay, But I want to introduce to you. Okay, I will share again. I want to introduce to you this one. Share application window. Okay, I will introduce to you this ChatGPT. We will ask it what it means by meant by Industry 4.0. Am I sharing the screen now? Okay. Am I sharing the screen correctly?
Yes, sir.
Okay. Now this is ChatGPT. Okay, we will ask ChatGPT what is Industry 4.0. I'm using this ChatGPT to help me in my work because sometimes I want to have the summary. Okay, let's see what is the answer of ChatGPT. Smart factories that can adapt to changing conditions and customer demands. Now, ChatGPT can answer so many of your questions. I am encouraging you all to use this to augment your workflow. You can use it for anything, especially if you're making code. You want to know the formula of this, you want to write some code for this, you want to get an Excel formula, you want to make a macro. So this can help you in your work. So I am strongly encouraging you to try this and see how it can benefit you. Now this is already free to use, and this is only the first version. The next version, of course, we are expecting to be even more powerful. So if you're not using this, then I think we are depriving ourselves of an assistant, of a very powerful assistant. Okay, so in anything that we are doing, let's see how can this technology can help us. This is free, and it will only get better in the next iteration of this technology. Okay, so in the ChatGPT is made by OpenAI. OpenAI is now about the $30 billion company. So they are improving this, and this will be integrated into all the products of Microsoft, or starting with Microsoft Office, and of course into the search engine. And it is a very viable competitor of Google. So now, Industry 4.0 means that we have smart machines. So this is about intelligence and automation. So much more automation, but with intelligence. In contrast with Industry 3.0, where we have used only computers and networking, telecom, data analysis, and the programmable logic controller. But for Industry 4.0, the main concept that we have to include is intelligence and automation. And so these are the main things. Of course, IoT is a big part of this because we need to have the data. We need to have the data to make some informed decisions. Okay, ma'am.
Sir, good afternoon, sir.
Good afternoon, ma'am.
Sir, is it Industry 4.0 leads to unemployment to Indian people, sir? Because when industries become smart factories, that means manufacturing industries become very smart. And then how it is possible to generate employment opportunity to people, sir? Is there any chance to lead unemployment issues?
Okay, the main thing about the main disruption with this artificial intelligence is always employment. So what we are seeing here is the employment will affect mostly the persons that are working the traditional work. Of course, this is bad. Now, For example, you have people who are not using computers. We have so many people doing that all over the world. We have that. So if these people, our countrymen are not using machines, then they will not be affected a lot by this. But if they are working on a factory where there is a pressure to automate things and to connect everything to the internet, they will be affected. Now, what can we do? Actually, this is a recurring worry, even for me. So when I'm thinking about this, if I'm working in a company and this company wants to put IoT, Industry 4.0, artificial intelligence, and all this, what can I do? If I am the employee, I have to think, will my skill be obsolete? If my skill will be obsolete, how can I move to another line of work related to my work? Or how can I augment myself so that instead of being completely replaced with artificial intelligence, I will be assisted by artificial intelligence to do better work. So the real worry is, if everything is automated, will all the human personnel be removed? Will it be working by itself? Now, we have to face this reality that in some industries, it will definitely, now that the main thing is, it will definitely happen. How can we prepare for this? Because if we will not prepare for this, can we say, can we stop this? Can the government do something to stop this march of technology? Now, for the governments, of course, they will be saying, can we stop this or it will affect the economy? Will our economy go down or go up if we did not apply this technology, if we do not embrace this technology? So the main thing is that I am also concerned, of course, I'm very concerned about this, is how can we prepare ourselves? Do we have to block this technology and say, okay, it is bad for us, I will not have anything to do with this? Or do we equip ourselves with the skills so that we can work alongside this technology? Okay? Because it will affect us eventually. It is only starting. So it's better we prepare now. So we have to upgrade our skills. Those industries that are primarily with manual work, well, if we can stay on the status quo, that, okay, we will make this as manual work because the machines cannot do it. Okay, it's better. But if there are parts of that industry which will be affected by artificial intelligence, it is better that we already make this as assistant to human capabilities. We cannot just say ignore it. We cannot go against it. We cannot put some government policies, okay, we will not automate this industry. What we can do proactively is equip ourselves. Because maybe it will affect us, maybe a little percentage, maybe a big percentage, but the main thing is we have to prepare. We cannot just say, oh, it's other people, other countries, not my industry. No. The technologies are seeping into every areas of all the industries. So if you stop one industry from doing this, what will happen? That industry might go down and it will affect more people. So my hopeful suggestion is that we go embrace it, equip ourselves. We cannot remain stagnant, and we cannot just we cannot ask the government to do some policies to, okay, stop this automation. So that is my opinion on the matter. Okay, thank you.
Sir, I have one doubt, sir.
Yes, sir.
Sir, in IoT, the main thing is a security risk. So in that security risk, the main thing is a data interception. So without our knowledge, our login credentials also just get to be snapped by others. So is there any particular level of algorithms or particular methods is just needed to avoid that data interception, sir?
The interception of data occurs at many levels. So even if your IoT device is connected only to your own network, it is not connected to the wider internet. Well, that is also one way of mitigating the security risk. Just connect it to a local network. The device security should permeate into every level of the chain, from the hardware device to the sensors, to the connection to the gateway, the network, the connection of the network to the bigger internet, and your local network. They should all be secured. So even without IoT, we already have problems with security. Right? We have a network of computers. Some hackers open our files. They introduce a virus. So even without IoT, it's already happening. But with IoT, the risk is so much greater because we have so many devices. How can we stop this? The solution should start at a very small level, then aggregation of the systems. There should also be a security. Then going to the network, the gateways, the routers, and so on. It should also be secured. Then now going to the wider network, then going to the wider internet. So there are different levels of security. Now, the policy that was implemented for all manufacturers of IoT equipment is to include security protocols and measures at the hardware level. So if you are a manufacturer making this sensor, making this microcontroller, and your sensor or microcontroller can connect to the IoT device or IoT or to the network, you should have this security device. The devices that we are using have this cryptographic chip, which will save our credentials, and for us, it will automatically save the credentials and prevent others from accessing this device. So that is the question of security is the biggest, and of course, I hope the succeeding speakers will talk about this in more detail because this is such a big topic. But the defenses of our system will be defenses in depth. In depth, it means every level will be connected. It will be provided with a security protocol. So it is not. If we cannot stop it, if we cannot stop this at the network level, maybe we can stop this before the gateway. If we cannot stop before the gateway. Can we stop this at the level of the systems or the groups of devices? If not there, can we stop this at the level of the individual device itself, the hardware level? So that is the thing that I can say about this matter. I hope the next set of the speakers will talk about this more in depth. Thank you, sir.
Thank you, sir. Thank you so much. We are very happy to have you at this juncture. Now, digitalization is transforming the industry. We need to update ourselves to meet the requirements. So, the session was very interactive, and many of the participants have gained. Even the participants were not able to join the Google Meet link by watching it on a YouTube link. So we are very happy to have you at this juncture. Also, you said you said about EIoT 3D printing technology, right? Which is very useful in nowadays, which plays a vital important role for the embedded sensors, which directly we can connect to the PCBs, allowing the sensors to be placed in a wearable devices in HMI applications. So thank you for your valuable session, sir.
Thank you, ma'am. Thank you to everybody. I hope I have you're not entirely disappointed with me. I hope I have shared something that will be useful to you. So to all, thank you very much, ladies and gentlemen. I am really grateful for your time.
Thank you, sir. Thank you so much. As you mentioned, on fourth day, Dwaragnath Rao Pawar is the cyber security consultant at TCS Chennai. He is going to give the elaborate details about the cyber security, sir. So it will be covered in this FTP. Now, dear participants, the feedback and the assessment link will be posted in chat box at the end of today afternoon session. kindly join at 1:45 p.m. in the same link for afternoon session. Thank you. Thank you, sir. Thank you, Gobal sir. Thank you, Jamil sir.
Thank you to
Thank
everybody.
you, Veer sir, for all of your valuable presence. Thank you. Thank you so much.
Thank you, ma'am. Bye.
Thank you, sir.
Thank you, sir. Thank you so much, sir.
Thank you, sir.
Thank you, sir.
Who's gonna